Okay, so this is the second video, and it's going to finish up Palant's example in on multiple regression, and pretty much we'll go through this fairly quickly because you've already seen a lot of what you need to know within in regression. But what we're going to do in this example is we're really going to ask whether or not there are other variables that maybe moderate the relationship between the two variables, predictor variables that we just looked at and their relationship with perceived stress. So we're going to go to regression in linear, and we're going to keep total score perceived stress here as the dependent variable. Okay, now let me get rid of these for just a second so that I can walk through this with you. Okay, so we're going to keep the dependent variable total score perceived stress scale. Okay, that's our y variable. Now what we're going to do is we're going to enter in those variables that we think might moderate the relationship between the two predictors we just used. And we're going to enter in block one, this is important to see, block one, age, okay, and then we're going to come down here to social desirability, the Marlowe-Crown scale. And so that'll go in. Now, these are the variables that we're interested in whether they have an effect on the other predictors. Okay, and once we take these into account, do the predictors still predict significant amounts of variance in the dependent variable? Okay, now we're going to click next, and what this will be, this is our first block. This becomes our second block. So now we're in block 2 of 2, and we're going to enter in the two variables that we just used, the total score on the mastery scale, and then the PCOISS scale. That's in block 2. So what the regression is going to do is it's first going to enter in that first block and get all the stats on that and see if we've got significant prediction then. Then it's going to enter in the second block, and the second block, what we'd like to see is that the second block, once it goes in, even with those first two variables in the equation, accounts for a whole bunch more variance in y than the first block did. Okay, so when we enter the second block, it's going to be all four variables together, not just these two by themselves. It'll be all four together. Okay, so we're going to go back into statistics, and this time I'd like you to have r squared changed. Check that off. That's really the only change I think that we're going to have. And the reason that we're going to do this is going to show us the amount of change in variance accounted for in the dependent variable y as a function of adding in the second block of predictors. Okay, and actually you'll see it for the first block too, but that's really just a change from zero variance accounted for when there are no predictors. So we say continue. Okay, I think options is going to stay the same. Yeah, plots are going to pretty much stay the same. Okay, and so let's go ahead and run it. Click OK, and up comes our output. And you're going to notice that there's a change now to our output because we have four predictors rather than two. So the first thing we notice right away is we get the mean age, and as well as the scores on the social desirability scale. So that's all there. Here are our correlations. Now we have correlations across all the variables, right? So we've got 1, 2, 3, 4, 5, including the dependent variable y, which is perceived stress. That always comes first. Okay, so you can see the relationship now. Now, just a quick inspection of these correlations, you'll notice right away that you've got relatively small correlations between age and the total score on the social desirability scale compared to these. So, right off the bat, I would be sitting here as a statistician looking to say, okay, we might see some relationship between age and social desirability with these other two predictors, but I'm thinking not. I'm thinking that these are still going to be the two most important predictor variables. Okay, you can look down here at significance of those correlations. Okay, this is just telling you which variables were entered and removed and when. So you'll see in Model 1 just includes social desirability and age. Okay, and basically it's asking, okay, compared to a model in which you have no predictors, does this add, a significant amount of variance predicted, just these two variables? Then you go to Model 2, it includes all four. So you'll see the mastery scale, the total score perceived control of internal state scale, plus these two that were already in there. Sometimes folks will look at this Model 2 and just say, oh, it's just these two, right? But actually, you're adding these two in to those variables right there. Okay? So now, what we're going to do is we're going to we're going to look at the amount of variability explained in Model 1. Okay, so this is just the social desirability score and the age score. Okay, you look at the R square and it's 0.057. That means about 5.7% of the variability in perceived stress is explained by these two variables. That's not very big. Okay, so a relatively small R square. Again, the adjusted R square is not a whole lot different because we have a pretty big sample size. And then we come all the way over to the R square change. Well, this is essentially the change from 0% variance accounted for to whatever Model 1 accounts for. So it's going to be equal to R square, right? It's a 0.057. And then you're going to get over here with this R square change statistic is whether or not the change is statistically significant. So this change to 0.057 or 5.7% of variance explained is in fact significantly different from having 0% explained. Okay, so you're going to see a significant F there. Now for Model 2, when you add in the other two variables, now you're looking at, in terms of the predictors, the Marlowe-Crown, age, the mastery scale, as well as the PCO-ISS. Look what happened to the R-square. It went all the way to 0.469. Okay, so 46.9% of the variance in perceived stress is now accounted for by these four variables, right? That's a big R-square change from 0.057. In fact, that change is 0.417. So if you add these two together, you're going to get 0.474. Okay, so 0.474 is our R square, 0.469 is our adjusted R square. That is a significant change. Both models are significant. They reject the null hypothesis. So even the first one, even though it didn't count for nearly as much variance, just those two variables, social desirability and age, still was a significant result. And then you get to the next one, and you'll see that the F ratio got huge, right? It went from 12.7 to 94.7. That just tells you that there's just a lot more variance accounted for, and it is a statistically significant F ratio. Now we want to know, well, which variables are the most important ones, okay, as individual predictors. Once you throw in our two control variables, you know, the mastery scale and the PCO-ISS, what happens to age and what happens to the Marlowe-Crown, and vice versa. So we're interested in that. We could look at the unstandardized coefficients, but again, they are on different scales and metrics. So we're going to skip that, come over here to the standardized beta coefficients. And these are, we're testing if they are significantly different from 0, right? So that's what the p-value is. Are these values, in fact, statistically significantly different from 0? For age and for Marlowe-Crown, the answer is no, right? That chance or measurement error could account for those standardized beta values. But for the master scale and for perceived control of internal states, we do get significant values. So what does this tell you in terms of the moderation hypothesis? We asked whether or not, in fact, let's go back. If we control for the possible effect of age and socially desirable responding, is this set of variables still able to predict a significant amount of variance in perceived stress? The answer is yes. And we know that the answer is yes because these p-values right here remain statistically significant even though we've taken these two other variables into account. Okay? All right. That's really the bulk of the finding. We've answered all of these questions, right? We answered the first question, how well do the two measures, how well do the two measures, let me see if I can get, there it is. No, there, okay, well, we'll just leave it there. How well do the two measures of control mastery, PCO-ISS, predict perceived stress? How much variance in perceived stress scores can be explained by scores on these two scales? We answered that question with the standard regression. Which is the best predictor? We answered that question with the standard regression, right? So we're able to see how much variance each of these predictors accounted for, and we were looking at those beta standardized betas in terms of that relationship. And then we came down here. So let me go back up. This first one here, of course, refers to the set of scores, and then this one refers to individual predictors. And then we asked whether other variables were sort of involved or moderated this relationship. Our answer was no, that they really weren't. Okay. We have other output. I'm not going to go into it because we talked about collinearity and residuals in the last video. So it's still there. We're not seeing anything sort of weird here. This is all just on a straight line. This scatter plot looks like a shotgun blast, right? It's just sort of a cloud of data points. That's what we want to see. So nothing unusual to warn us of any sort of issues with residuals or collinearity. So all looks good. We've answered the questions. And I would direct your attention to page 168 in Palette. It's going to give you the write-up for how to write up your results for this example. I'd like you to take a look at that because when you get to the Wawa, you're going to want to write up results. And also on the final, there's going to be a question with regard to multiple regression. You're going to want to know how to, on the take-home final, you're going to want to know how to write up the results there. So that's pretty much it. You are good to go. I think, if you have any questions, make sure to holler at me. But why don't you go ahead into the Wawa and then run the example and see if you can interpret those results. If you have any trouble, send me a text message, send me an email. Smoke signals, like I said, are always pretty good. Don't call 911. They're not very helpful. So at any rate, good luck, and hope that you do well on this, okay?